Hi everyone, today we are going to revise for our system-wide quiz 2. The first KPI that you will be asked for is 7.5. Here you need to be able to define resonance. What is resonance? Resonance is a condition that occurs when more than one valid Lewis structure exists for the same molecule. In our syllabus, we have some examples of resonance, like CO3. We call this carbonate, NO3, nitrate, NO2, nitrite, SO3, sulfite, and SO2 and O3. O3 is ozone, SO2 is sulfur dioxide. Let's take an example. Ozone. Ozone is O3. How can we represent resonance? By drawing two possible forms, two possible structural formulas. O3 means oxygen atom and linked to two other oxygens. Here, these are the valence electrons. This is ozone molecule. Secondly, we have SO2. SO2, sulfur dioxide. I told you in previous slides that if we have a double bond between O and any other atom, you should draw 4 valence electrons. If there are 3, draw just 1 pair. And if there is 1, draw 3 pairs. This is SO3 molecule. Where is the resonance here? Resonance happens when you change the position of the double bond. Like here, I can draw the molecule in this way. This is the second resonance form. And for SO2, also you can draw it like this. Change the position of double bond. Example 3 is CO3. Let's see how to draw CO3. The molecule is trigonal planar, if you remember. Angles between bonds are expected to be 120, and this is the structural formula. You can draw it also in the other way around by changing the position of double bond. Also, I can draw the double bond on the right side. After that, you just need to draw to show the electrons. Here, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Here, double bond just 2. Here, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay, and don't forget that this is an ion which has a charge -2. The charge should be shown when you draw the resonance structure. So all of those are resonance form for carbonate ion. Number 4, nitrate, NO3. NO3, here, you can expect that you can draw also another resonance form for nitrate, where you can change the position of the double and single bond. So you can put the single bond here or on the left side and complete the drawing of the molecule. We have also to know structure of other resonance form like nitrite, NO2. This is the nitrite molecule. You can expect that you can draw only one more form where the double bond comes on the left hand side. Here is the structure of sulfite ion. There is a lone pair of electrons because sulfur is in group 6 and has 6 electrons in the outer shell. So 1, 2, 3, 4, 5, 6. You can see that there are 3 apparent resonance form for sulfite because you can put the double bond either on the left hand side or downward. And in each form, don't forget to draw the electrons. 4, 1, 2, 4, 6, 3, 4. 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, and 1, 2, 3, 4. Don't forget also to draw the charge on each ion. Lastly, we need to know the structure of sulfur dioxide molecule. Sulfur dioxide remaining electrons are 4 on this oxygen atom, 6 on this oxygen atom, and don't forget that the whole molecule here is neutral. This is the structure of sulfur dioxide molecule. The other resonance form is by alternating the position of the double bond, making it on the left hand side. Don't forget about this plus and minus. You will not be asked for, but this is for accuracy of the drawing. Now we'll start in KPI 8, which is the next section. It's about the chemical reaction, chemical equation, how to write a balanced chemical equation. First KPI is 8.1. He is asking you about definition of chemical equation. What is a chemical equation? Chemical equation is a representation of a chemical reaction using chemical symbols, formulas, and numbers to indicate reactants and products. Second KPI, distinguish between chemical reaction and chemical equation. In chemical reaction occurs when reactants are converted into products. This is a chemical reaction, and it has signs that we are going to discuss it in the next slide. While chemical equation, as we have just said, it uses chemical symbols and numbers to indicate reactants and products. So very simply, you can say that in the chemical reaction, it shows when the reactants are converted into products, while the chemical equation, it indicates the conversion of reactants into products. So the signs of chemical reaction, we can summarize them as release of gas in the form of bubbles or effervescence, release of energy in the form of heat or light, color change, formation of a precipitate or an insoluble solid. The next KPI describe what do the arrows and the coefficient mean in a chemical equation. Let's take an example. If I say C plus O2 equals CO2, what does the arrow mean? Arrow, it separates reactants from products and specify directions. So C plus O2 are reactants, carbon dioxide is representing the product. The arrow shows you that reactants are converted into products or carbon plus oxygen react to give carbon dioxide. So it separates them and specify the direction of the reaction. While coefficients, they specify the relative amount of the components. So if we make a reaction between hydrogen and oxygen to produce water, this is the balanced equation. This 2 is a coefficient, and this 2 also we call it coefficient. What does it show? It shows that 2 molecules of hydrogen react with 1 molecule of oxygen to form 2 molecules of water. So it does show the relative amount of the component of the reaction. KPI 8.6 shows the meaning of different symbols that are used when you write chemical equation. In the previous equation, we wrote hydrogen plus oxygen to give water. Here, hydrogen is gas, so it's represented by G. Water, if it's produced in a form of steam, you should write G because it will be in the gas form. If it's written in the form of a solid, like if it's an ice block or something, so I can write S. If it's in the form of liquid water, like the normal state of water, so you write L. So the product state depends on what the form of water will be produced. If it's in the form of steam, you write G. If ice, you write S. If liquid, write L. So we learned 3 symbols. S identify a solid state, and L identifies a liquid state, and G identifies a gaseous state, while AQ, aqueous, this identifies a solution of water. Like when a salt dissolves in water, I can say if you have sodium chloride salt and you dissolve it in water, so it's going to form sodium chloride solution. You should represent it as AQ. In KPI 8.7, explain why it is important to balance a chemical equation and identify what is conserved. Looking back at the law of conservation of matter, which says that the number of atoms of all elements must be equal on both sides of the reaction arrow. So if I start a reaction with two hydrogen molecules, mean that I have 4 hydrogen atoms, and 1 oxygen molecules means that 2 oxygen atoms. You should also finish your reaction with a molecule which has the same number of atoms. So I have here also 4 hydrogen atoms and 2 oxygen. This means that the number of atoms before and after the reaction should not change. In chemical equation, mass and number of atoms are conserved. So the number of atoms, the mass of atoms should not change before and after the reaction. This what's meaning by what is conserved, because if you go back to the KPI, it's saying why it is important to balance a chemical equation. Let's answer this question. Why it's important to balance? Because mass is neither created nor destroyed in chemical reaction, according to the law of conservation of mass, and you can also mention the law of conservation of mass. The second part of KPI was saying identify what is conserved. What's conserved is the mass and the number of atoms. Next KPI 8.8, list the 4 guidelines that are useful in balancing an equation. So, first thing is to balance different types of atoms one at a time. Different types of atoms one at a time. 2. Balance type of atom that appear only once. Balance only atoms that appear once. Firstly. 3. Balance single units. Any polyatomic ions that appear on both sides. So any polyatomic ion, balance it as a single unit or a single atom. So if I have 2, for example, 2NO3, what I will say? I will say I have 2 ions of nitrate. Don't say I have a 2N and 6O. Don't say that. Number 4, balance hydrogen and then oxygen last. So the last atom that you should balance are hydrogen and then oxygen. In 8.9 KPI, you need to learn how to balance chemical equation. So we should practice balancing of many chemical equations here. Example 1. KNO3 gives KNO2 plus O2. How to balance this kind of equation? First, look at the atoms that are used only once in equation, like potassium. I have 1 and 1, so it doesn't need balance. Look for NO3. If you need to treat it as one unit, as we have mentioned there, I can't do it here because I have NO3 on one side of the equation and NO2 on the other side. So you'll treat each atom as single. I have here one nitrogen and one nitrogen, so N is balanced. 1, 1. Potassium, K, K. Oxygen, I have 3 oxygen on the left side, and 2 plus 2, we have 4 oxygen on the right hand side. So oxygen needs to be balanced. The only thing that you can do is to change it into 6. So if I put here 2 and here 2, you should rebalance again everything in the equation. Two potassium on the right and 2 potassium on the left, 2 nitrogen on the right, on the left, and 2 nitrogen on the right. 2 multiply 3, I have 6 oxygen on the left. 2 multiply 2, 4, plus 2, we have 6 oxygen on the right. This means that the equation now is balanced. H2 plus S equals H2S. This equation does not need any balance as the number of atoms were equal before and after the reaction. D CuSO4 plus H2O gives CuSO4 on applying heat. It will change into CuO plus SO3. Also by counting, this equation doesn't need any balance. Let's balance those equations. Equation 1, BaCl2. Comparing the barium, it was 1 before and after. Cl2, I have on that side 2Cl and on the other side 1. So I'll add 2 here in a coefficient. So now the Cl is 2 and 2. Sodium, 2Na or Na2 means 2 sodium atoms, and here also we have 2 sodium atoms. Sulfate, I have 1 SO4, and on the other side we have 1 SO4. So the equation is balanced now. Equation 2, H2SO4 plus NaOH give Na2SO4 plus water. Let's look first at sodium. I have 1 sodium and the 2 on that side, so I'm going to write 2 here, making it 2 sodium atoms on either side. Then looks at SO4, I have 1 and 1, so we don't have a problem here. Then we make oxygen, hydrogen, and then oxygen to be the last. Let's balance hydrogen. How many hydrogen do we have on that side? 2 plus 2, 4. And on the other side I have just 2. So we need to multiply by 2 to have 4 hydrogen. Oxygen, now 2O, and on that side 2O. So oxygen, it balanced now. In this equation, look for at copper, 1 atom and 1 atom, so it's balanced. Sulfate, 1 and 1. Sodium, 2 and 1. So we need to multiply this side by 2 to make it 2 sodium atoms. When you make these 2 sodium atoms, Cl now is 2. And on the other side I have 2 Cl. So the equation now is becoming balanced. This equation, C2H5OH plus O2 giving CO2 plus H2O. Look at the carbon, 2 carbon and 1, so I will write 2 here. Then look at hydrogen. I have 6 hydrogen on that side and only 2 on the right side, so I'll multiply the 2 by 3, making it 6 on either side. Oxygen, here I have 1 O plus 1 O2 means 2O. I have 3O on the left hand side, and we have 4 plus 3, we have 7 on the right hand side. So oxygen needs to be balanced. In order to balance oxygen, try not to change the atoms that you balanced earlier. So I don't want to try to touch the atoms that we already balanced. I will try to make something here. If I make here this 2O2, making it 4, it will be 1 plus 4, 5. So it's not yet 7. But if I write here 3, 3 multiplied to 6, so I have 7 oxygen on the left side and 7 oxygen on the right side. I hope you understood how to balance equations, but you need to practice many and many more. To recap the balance of this equation, we started with C2H5OH, looking for first at carbon. It was 1, 2 on that side, and 1 on the other side. I made it 2. And then I looked at hydrogen. I found it 6 on the left hand side and 2 on the right hand side. I multiplied by the coefficient of 3 to make it 6 on either side. And then by looking at oxygen, we found that the equation is not yet balanced. I have 3 oxygen on one side and 7 oxygen on the other side. So the only way is to add more atoms to the O2, which is single, because if you try to change the number of oxygen atom on any other side, you are going to rebalance the whole molecule and it will not be correct finally. So try to add as many oxygen as you can here in order to make both sides equal. I multiplied by 2, it became 5, which is not correct. So I multiplied by 3, making 6 plus 1, 7 oxygen on the left hand side, which are equivalent with 7 oxygen on the right hand side. 8.10 Identify quantitative information revealed by a chemical equation. Quantitative information, we mean the number of molecules, atoms, ions of each element composing reactants and product. Mean that you need to be able to count the number of atoms that enter and produce from reaction, number of ions, number of molecules. Let's take an example that we have just done. NaNO3 give NaNO2 plus O2. Here is the balanced chemical equation. You should be able to say that 2 sodium atoms on here and the 2 sodium atoms there. I have here 2 nitrate ions, and on the other side I have 2 nitrite ions. Okay, and on the right hand side we have 1 oxygen molecule. If you count it with atom, I can say I have 2 oxygen atoms. Next KPI, you need to be able to write word equation for a chemical reaction and vice versa. So you may get in the exam chemical equation like the one I wrote above, and you are asked to change it into word. So I will write sodium nitrate solution gives sodium nitrite solution nitrite solution and oxygen gas. You might be asked to represent a reaction using a particulate. So I can say like this. So what can we say here? For example, if you have O2 plus H2 give H2O molecule. We need to balance, make sure that the equation is balanced. In order to balance the equation, we started with 2 oxygen, so I should draw another oxygen with 2 H, so making 2 water molecules. So I should write here 2. And for hydrogen, we have used here 4 hydrogen atoms. So also I need 2 hydrogen, 2 more hydrogen to be added. This is a balanced chemical equation. Okay, and here is the particulate model. So a particulate model or a chemical equation or word equation. Word equation, I will say oxygen gas plus hydrogen gas gives water liquid. Point 12. You are asked to define and give general equations for the 5 basic types of chemical reactions. What are those? Synthesis reaction, combustion, decomposition, single replacement, and double replacement. In synthesis reaction, here 2 or more substance react to form a single product. Like when we say A plus B equals AB, or when I say NH3 plus HCl gives NH4Cl, or when we say O2 plus 2H2 equals 2H2O, or when we say C plus O2 equals CO2. In all of those reactions, we started with 2 and end with just one product. Second type of chemical reaction is combustion. Combustion means burning in oxygen. So it's a simple type of synthesis reaction where an element combines with oxygen to form an oxide. Like when I say C plus O2 equals CO2, or H2 plus O2 gives H2O. So a reaction between substance A and oxygen to produce an oxide of AO2. This is the general formula. 3. Decomposition. In decomposition reaction, it's a chemical reaction in which a single compound breaks into two or more elements or new compounds. Like when you have a big molecule and you break it into smaller ones. This is an example of decomposition reaction. Or I can say AB decompose into A and B. In chemistry, we can give some examples like KNO3 decompose to give KNO2 plus O2. Or when we say CuSO4 decompose to give CuO and SO3. Fourth type of chemical reaction is single replacement. In single replacement reaction, atoms of one element replace the atoms of another element. In a compound. So you will be having a compound like Bx. Atoms of A can replace atoms of B in the molecule Bx, forming an Ax and B. We are going to discuss later so many examples of this type of chemical reaction. Let's take just two examples here. Zinc replaces hydrogen, giving ZnSO4 plus H2. Or similarly, if you say Zn plus CuSO4, zinc is going to replace copper, forming ZnSO4, and copper will be left behind. In double replacement reaction, here it involves exchange of ions between two compounds. So if you have two compounds like Ax plus By, the positive ions will be exchanged between the two compounds. So the A plus ions will join the Y minus, forming AY, while the B plus ion will join X minus, forming BX. This KPI is to identify the reaction type when a chemical equation or a particulate diagram is given. When a chemical equation or a particulate diagram is given. So again, here one molecule of water decomposed to form two small molecules of hydrogen and oxygen. So when you see a big molecule has been broken down into two small ones, this indicates decomposition reaction. In single replacement, if you have an atom of zinc, react with, by looking at this reaction, you recognize it's a single replacement reaction, because here, this atom, the white atom, has been replaced the green one. An example of this reaction, zinc plus copper sulfate, giving zinc sulfate plus copper. So copper has replaced zinc has replaced copper in this reaction. In this double replacement reaction, you can see that we have this compound expecting, like you can say AB, with a compound like CD. The result now is AD plus C or BC. So very simply, when you make a chemical reaction, the positive ions are exchanged. In such a way, the two ions closer come together and the two ions that are away will go together. So, in chemical activity series, metals are ordered according to their activity in a way that the most active metal are at the top of the list, while the least reactive one will be at the bottom. Here is a chemical activity series of metals, starting from the most reactive to the least reactive. So the most reactive metal is at the top of the series, and the least reactive one. So from this chemical activity series, we can recognize that lithium is the most reactive metal, while the least reactive one, according to our series here, is Au, which is gold, least reactive. The theory is saying that the most reactive metal can replace the least reactive one in one of its salt solution. So if I say zinc plus copper sulfate, to predict if this reaction will take place or not, looking up both metals, zinc and copper, in the chemical activity series, you recognize that zinc is coming before copper, or means that zinc is more reactive than copper. So the reaction will take place. Zinc is going to replace copper, forming zinc sulfate and Cu. In the same way, if I say calcium plus MgNO3, looking up the table, you will see that calcium comes before magnesium, so the reaction will take place. Calcium is going to take the place of magnesium, forming calcium nitrate, plus magnesium. Let's take another example. Fe plus ZnSO4. Looking at the table, you will see that Fe is coming after zinc, so Fe is less reactive. So this means that Fe cannot replace zinc, so you can say no reaction here. Similarly, the reaction will happen if a metal is to replace hydrogen of an acid. So Zn plus H2SO4, it will give ZnSO4 plus hydrogen. This is because zinc is coming before hydrogen in the chemical activity series. While copper can't react with sulfuric acid because copper is less reactive than hydrogen. So no reaction. Okay, while aluminium can react with an acid, forming aluminium chloride and hydrogen. And the higher the element of the series, the easier for the reaction to take place. Now here the reaction is fully balanced. 2 aluminium on either side, 6 hydrogen on either side, and 6 Cl on both sides. The chemical activity series of halogen is as follows: fluorine, chlorine, bromine, iodine, and astatine. With fluorine is the most reactive and astatine is the least reactive. So the most reactive one is fluorine, the least reactive one is astatine. This table will not be given to you in the exam because it does follow exactly the location of the element in the periodic table. So by looking up the element in group 17, you can recognize the trends of reactivity. Also, you should be able to recognize the trend of this chemical reaction. So if I say fluorine plus KCl, you should predict that this reaction should take place because fluorine is more reactive than Cl. So it is going to give KF plus Cl2. Fluorine is replacing halogen, the other halogen. And the equation, of course, it does need balance. In the similar way, bromine can react with NaI because bromine is coming before iodine and it's more reactive than iodine. So it will give NaBr and I2. Bromine is replacing iodine. But if we say the opposite, if I say chlorine plus NaF, this reaction won't take place because chlorine is less reactive than F. No reaction. In section 9, you are going to describe the products of different types of chemical reaction. KPI 1 is to list 3 common types of product produced by reaction that occur in aqueous solution. Let's take example 1, reaction which involves production of a gas. Like if I say Na2CO3 aqueous solution plus HCl, also aqueous solution of an acid, this is going to give sodium chloride plus water plus carbon dioxide. So here gas is produced. Also, if you make a reaction between any metal, reactive metal than hydrogen and an acid, the metal is going to replace the acid, giving salt, and gas will be given out. A reaction which involves liquid, it's most commonly neutralization reaction, because in neutralization reaction you make a reaction between an alkali like sodium hydroxide, acid like HCl. This is going to give sodium chloride, which is in aqueous solution as well, and water. All kinds of neutralization reaction like those produces water. C, reaction which involve a solid, could be a precipitation reaction, like if I say sodium chloride plus silver nitrate, both of them are aqueous solution. They are going to react producing silver chloride, it's a solid or insoluble precipitate, and sodium nitrate, which is also aqueous solution. Compare and contrast chemical equation and ionic equations. What is the difference between the chemical equation and the ionic equation? You know, if compare and contrast, in this KPI, you should compare and contrast chemical equation and ionic equation. Chemical equation and ionic equation, both of them describe the conversion of reactants and products. But the chemical equation, it uses formulas and symbols to describe identities and relative amount of reactant and products. It shows how many atoms of each of the elements and compounds are taking part in reaction. While the ionic equation, it shows the electrolytes. We mean here the ions in aqueous solution are written as separated ions. Electrolyte, you can change it with aqueous solutions. So the ions in aqueous solutions are written in the form of dissociated ions or separated ions. Like if I say for a chemical equation, sodium hydroxide reacts with hydrogen chloride to form sodium chloride and water. This is a chemical equation. If I need to change it into an ionic equation, you need to change all aqueous solutions into ions. And this is the ionic equation. So you will change sodium hydroxide into sodium positive ions and OH negative ion plus HCl hydrogen positive ion and Cl also negative ion. The product will be sodium chloride, sodium positive ion, and Cl plus H2O liquid. Remember that solids, liquids, and gases are non-ionizable. So you cannot change solid, liquid, or gas into ion. You cannot dissociate solid, liquid, or gas into ion. Just leave it as it is. Here is the last KPI required for your system-wide quiz. It's to distinguish between net ionic equation and complete ionic equation. In a complete ionic equation, all dissolved ions in ionic compounds appear as free ions. Like when we say copper sulfate plus sodium chloride, it will give copper chloride and sodium sulfate. To convert it into an ionic equation, you just need to replace the aqueous solutions into separate ions. So Cu2 plus SO4 minus plus NS plus Cl minus, giving Cu2 plus 2Cl minus plus 2Na and SO4. This is a complete ionic equation. It just shows all aqueous solution in a form of dissociated ions without cancelling any of them. While if you want to write net ionic equation for a reaction like between BaCl2 and CuSO4, both of them are aqueous solution. They give CuCl2, it's an also aqueous solution, and barium sulfate, which is a solid or a precipitate. To represent this with ionic equation, you are going to dissociate all aqueous solutions into dissociated or separated ions. And don't forget to write the state symbol. Copper plus sulfate CuCl2 2Cl. Yeah, the only change, the only the compound that you leave is barium sulfate because it is non-ionizable, so you leave it as solid. The last step you do is to cancel out spectator ions, the ions that are not changed during the reaction, like chloride ions, they are repeated without any change. Copper ions, okay, also are cancelled out. So the net ionic equation will be Ba 2 plus aqueous plus SO4 aqueous giving BaSO4 solid. So the only change happening in the reaction is reaction between barium positive ion and sulfate negative ion to give white precipitate of barium sulfate. So it shows only the particles that take part in the reaction. All other particles are spectator and should be removed from the net ionic equation. While the complete ionic equation have shown all the particles. Thank you.